that is rational numbers. Here you can see that I am having a bag of numbers from class 6, 7th and then now I am in class 8. I have collected a lot of numbers in between that. First of all, I have collected natural numbers. In that I was having 1, 2, 3, 4, 5, such numbers were there in my bag. So, but later on when I introduced 0 in my bag, then I was having a collection of whole numbers with me. Later on I have found some negative numbers also. Then now my collection has become of integers. Then I found some numbers like 3 by 5, 4 by 7. These numbers were fraction. Now there are some more kind of numbers. These fractions were in the form of p by q. Okay, the p is called numerator, the number which is written at the top is called numerator, and the number which is written at the down is called denominator. Now I found some more numbers such as minus 3 by 7, minus 2 by 6. So I found that these are not fraction. We have to give it some another name. That name is given as rational numbers. So for any number to be rational number, there are 3 important conditions. Number 1, it should be in the form of p upon q, where p is numerator and q is denominator. And second condition is that this p and q are integers. Integers means it can be positive, it can be negative, it can be 0 also. Whereas it was not in the case of fraction. And the second point, that the denominator q should not be equal to 0, because if it is 0, if q is equal to 0, then p by q is not defined. Why I am saying not defined? If I will divide, what does p by q means actually? This p by q means that if I am dividing this number, then p should be inside, like p will act as dividend and q should be outside. Q should act as divisor. If I will divide any number by 0, then we don't have any table of 0 for which we can get a value of p or less than this. Like for 0, we can't read any table. That's why if q is equal to 0, then p by q is not defined. So this we have to take care that whether it is rational number or fraction also, denominator can never be 0. Fine. So for rational number, there are 3 important conditions. In this way, how we can define rational number? That a rational number is a number which can be written in the form of p upon q, where p and q are integers and q is not equal to 0. In short, what we can say, that rational number is a combination of fraction, which we have studied before, plus integers. Like if I will add both the concepts of fraction as well as integers, then I am having a collection of rational numbers. Why I am saying fraction? Because fractions are also in the form of p by q. Why I am saying integers? Because p and q are integers. So the combination of both fraction and integers together form rational number. So in this way we can define rational number by using these 3 conditions. That rational number are expressed in the form of p by q, where p and q are integers and q is not equal to 0. Now we are going to study some properties of rational numbers while comparing it with properties of whole numbers as well as natural numbers as well as integers. Here I have written properties of different types of numbers. From class 6, 7, now you are going to start class 8. In class 6, 7th, already you people have studied these properties several times. Same properties, closure property, commutative property, associative property, distributive property, additive identity and multiplicative identity. These 6 properties in class 6 you people have studied about whole numbers and natural numbers. Then in 7th you have studied the same properties for integers, and the same we will be studying right now for rational numbers. So it's all a recapitulation of all the topics, all the properties which you have studied from class 6 to 7, and now it's for 8th also. So examples we will discuss orally, and we will check that where the property is being satisfied and where it is not. So I have made a table. You can see here I have written in a vertical column, I have written all the 6 properties: closure property, commutative property, associative property and so on. Similarly, in the second column I have written operation. All the properties we have to check mainly for 4 basic operations in all the cases: plus, minus, multiply and divide. Plus, minus, multiply and divide. Plus, minus, multiply and divide. Okay, so we will be checking all the properties for these 4 operations. Now first of all we are talking about whole numbers. Whole numbers starts from 0 and tends to infinite. Okay, so what the closure property says, I have explained before also, that in closure property means something is closed. Okay, if I am saying something is closed, means you have set a boundary for those numbers. This is my boundary of whole numbers. This whole boundary of whole numbers, in which inside all are whole numbers. So if in this boundary I am taking any 2 whole numbers, supposedly I am taking one whole number I have taken as 2 and the another whole number I have taken as 5. So when I will add these 2 whole numbers, 2 and 5, 2 plus 5 is 7. So it is coming in this boundary only, boundary of whole numbers. So what I will say, that whole numbers are closed under addition. So 2 plus 5 is 7, so it is closed under addition. Now we will check for subtraction. 2 minus 5. 2 minus 5 is minus 3. So this was the boundary for whole numbers. Minus 3 is not coming under this boundary. Minus 3 is outside the boundary of whole numbers. So what I will say, that whole numbers are not closed under subtraction. For multiplication, 2 into 5, 10. Again, this 10 is also coming under the boundary of whole numbers. So this is whole numbers are closed under multiplication. For division, 2 upon 5. So 2 is not divisible. When I will divide 2 by 5, it will not come a whole number. Again, this is out from the boundary. So not closed. So whole numbers are not closed under division. Whole numbers are closed under addition and multiplication, but not closed under subtraction and division. Similarly, we can check for natural numbers, closure property. Now again, this is the circle of natural numbers. Now I will take 2 natural numbers, 3 and 7. I will add it. 3 plus 7, 10. So natural numbers are closed under addition. 3 minus 7, it is coming minus 4. So it is not closed under subtraction. Minus 4 will go outside the boundary of natural numbers. Now if I will multiply it, 3 sevens are 21. Again it is coming inside the boundary of natural number. So it is closed under multiplication. And for divide, 3 upon 7, it is not closed under division. For subtraction, again I can take 3 and 7, we can continue. 3 plus 7, 10. It is integers. Now the boundary is of integers. Boundary is extending right now. Now the boundary is of integers. 3 plus 7. It is closed. 3 plus 7 is 10. So integers are closed under addition. Now for subtraction, 3 minus 7. It is coming minus 4. Now minus 4 is also coming in the group of integers. So subtraction also it is closed. Integers are closed under subtraction. When we will multiply, 3 sevens are 21. again it is closed. But when we will divide 3 upon 7, so 3 upon 7 is not in the group of integers. So integers are not closed for division. For rational numbers we will check, like it's in the form of p by q. When you will add any two rational number, it will come a rational number. So it is closed under addition. For subtraction, since rational numbers can be negative also, so if it is coming negative answer, no problem. It will be in the category of rational numbers only. So closed under subtraction. For multiplication also it is closed. For divisions, supposingly if I am dividing any rational number by 0, so we have studied that if I am dividing any number by 0, then it is a case of not defined. So rational numbers are not closed under division. So we have studied closure property for all kinds of number. Similarly, commutative property. Like for closure property, we have formed boundary of that given numbers. We have formed a closed boundary of that numbers. But for commutative property, how we have memorized it? Like commutative, it is related with the word communication, and the best communication is always between two people. So in commutative property, two numbers are involved. So like two numbers, I am taking 2 and 3. 2 plus 3 is 5 and 3 plus 2 is also 5. So simply we are reversing the order. In commutative property, here I will write in short that a plus b is equal to b plus a. This is all about commutative property. So if it is only in case of addition and multiplication, the reverse order is same. But in case of subtraction and division, the answer changes. So in all the four cases, whole number, natural number, integers and rational number, all are commutative under addition, but not commutative under subtraction. They all are commutative under multiplication, because 2 3s are 6, 3 2s are 6. Similarly, 2 by 3 into 4 by 5 gives the same result as 4 by 5 into 2 by 3. In addition and multiplication, reversing the order doesn't change the answer. But in subtraction and division, they are not commutative. Similarly, in associative property. Now, associative word is related with association. And association is never for two people or one people. It is always more than two. So, in associative property, we are having three members. So, three numbers. A plus B plus C is equal to A plus B plus C. Now, you can see both are same. Then, what is the difference? Difference is, like first we will add A and B in the first case, and then the result will be added to C. But in the second case, first I will add B plus C. First we used to solve the bracket. So first we will add B and C, then the result will be added to A. So again, for all the four numbers, all the four types of number are associative under addition and multiplication only. Because addition and multiplication, if we are changing the order, it never fixes the answer. So they all are associative for addition, but not associative for subtraction. They all are associative for multiplication, but not associative for division. You can justify all these properties by taking some examples. Okay, now for distributive property. The word distributive means divide. Okay, so supposedly this 8 into B plus C I am writing. This can be for two operations. Multiplication over addition or multiplication over subtraction. If it's multiplication over addition, then 8 into B. This is bracket. First I will multiply A by B, then A by this plus will come, and then A into C. Now for this, first I will multiply A into B, this minus sign will come, and then A into C. So what I have done, I have distributed this A over B and we are wearing ID card, which gives our identity. So in identity we have to take care that the identity of the number should remain same. So additive identity means what number should be added to any number so that its identity remains same. So it's very easy to think that if I will add 0 to any number, the number will remain same. So 0 is called additive identity of any number. Similarly, for multiplicative identity, by what number any number should be multiplied so that the result remains same or the identity of the number remains same. So the answer comes 1. If I will multiply any number by 1, the number will remain same. That's why 0 is called additive identity and 1 is called multiplicative identity. So this was all about properties of different types of numbers for whole numbers, natural numbers, integers and rational numbers. We have discussed all the 6 properties. Differentiate between what is additive inverse and what is multiplicative inverse. Additive inverse is related with the word additive identity and multiplicative inverse is related with the word multiplicative identity. So 0 was additive identity and 1 was called multiplicative identity. When a number is added to its additive inverse, the result is 0. Additive inverse must be related with addition. So in this, when any number is added to its additive inverse, the result should be 0. Similarly, when a number is multiplied by its multiplicative inverse, the result is 1. In multiplicative inverse, we have to multiply. So when a number is multiplied by its multiplicative inverse, the result should come 1. And how we get the additive inverse? Additive inverse is obtained by reversing the sign of number. Supposingly I am having plus 3, then additive inverse of plus 3 will be minus 3. Additive inverse of minus 1 by 5 is equal to 1 by 5. So what we are doing for additive inverse? We are simply changing the sign of number, or I can say we are reversing the sign of number. If it's a positive number, then we have to make it negative. If it's a negative number, we have to make it positive. Additive inverse we can find for natural number also, whole number also, integers also, as well as rational number. Similarly, how multiplicative inverse is obtained? Multiplicative inverse is obtained by interchanging its numerator and denominator. In this, the role of numerator and denominator is important. So, for any number, we have to check what is its numerator. For example, I want to know the multiplicative inverse of 3 upon 5. So, numerator is 3 and denominator is 5. So, its multiplicative inverse will become 5 upon 3. I have reversed the numerator and denominator. And this multiplicative inverse is having one more name, that is called reciprocal. Reciprocal of any number, or I can say multiplicative inverse of any number. So we can take a few examples for this. Like additive inverse I am taking. Additive inverse of minus 3 by 5 is 3 by 5. Additive inverse of 1 by 2 is minus 1 by 2. Additive inverse of minus 3 upon minus 7. Now here you can see both are having minus sign. So in all this number is positive because both the minus signs will be cancelled. So its additive inverse is minus 3 by 7. So these are additive inverse. Okay. Similarly we can see multiplicative inverse of few numbers. Let's take the same example. Multiplicative inverse of minus 3 by 5 is 5 upon minus 3. Either I can write it as 5 upon minus 3 or minus 5 by 3 or minus in center 5 upon 3. This minus sign simply denotes the negative number. It's not that this minus is only should be with numerator. This is is not the case. This minus you can place either in denominator, or you can place it in numerator, or you can simply place it in the center of the number also. Now multiplicative inverse of 4. Now I have written only 4. So how I can interchange the numerator and denominator, since I am not finding any denominator here. If there is no denominator, we take it as 1. In case if there is no denominator below any number, we will take it as 1. So multiplicative inverse of 4 by 1 is 1 by 4. One more example I am writing, like 2 and 1 by 5. This is a mixed fraction. So this mixed fraction should be converted to first improper fraction. 5 2s are 10, 10 plus 1, 11 upon 5. So now we have to find multiplicative inverse of 11 upon 5. It's not possible to find multiplicative inverse of 2 and 1 by 5. We have to first convert it into improper fraction. Then only we can find its multiplicative inverse. So multiplicative inverse of 11 by 5 is 5 upon 11. So you all can see that what I am doing in additive inverse and what I am doing in multiplicative inverse. In additive inverse, simply we are reversing the sign of that number. If it's negative here, it will become positive on other side. If it's positive, it will become negative. If both are negative, means the whole number is again positive. So its additive inverse will be negative. In case of multiplicative inverse, what we are doing? We are interchanging the numerator and denominator. This we have done in all these examples. So we can have many questions related to this additive inverse or multiplicative inverse. For example, question can be multiply 5 by minus 3 with multiplicative inverse of 4. So what you will do, first you will find multiplicative inverse of 4, then you will multiply these two numbers. Or question can be, is 3 and 1 by 3 is multiplicative inverse of minus 10 by 3? I will write this question. The question is 3 and 1 by 3 is multiplicative inverse of minus 10 by 3. So without doing any calculation, just by observing the question properly, you can say that no, it's not multiplicative inverse. Why I am saying so? Because see, here the number is positive and here the number is negative. In multiplicative inverse, there is no change of sign. So definitely this will not be the multiplicative inverse. Now what will be the multiplicative inverse? When you will convert this to improper, 3 3 is 9, 9 plus 1, 10 by 3. So this is the actual number. So its multiplicative inverse will be 3 upon 10, not this. Okay, so in this way we can do many questions related to additive inverse or multiplicative inverse, or the question can be very simple also, direct question, find the additive inverse of these numbers or find the multiplicative inverse of these numbers. Now we will learn how we can represent any rational number on a number line. We have learned some properties of rational numbers, whole numbers as well as natural numbers, integers. So now we will be doing some questions related to those properties of numbers. Okay, now first of all, this is a simple problem which you can see that simply they are having only plus and minus sign. So in this, no specific property will be used. We have to solve it by using simple calculation. In the first question I have told you, we have discussed that whenever we are solving any these all are rational numbers because they are in the form of p by q, as well as they are having some negative rational numbers also or some positive rational numbers also. So what we have to do is a simple question of fraction, you can say, in which integers is also used. So how, whenever we are adding any rational number or subtracting any rational number, then what we have to do, we have to check the denominator. Are they all same? If they are same, then well and good. If they are not, then we have to make it same by finding the LCM of all the denominators. Before that, first find, we can see that here I am having two signs, plus also and minus also. Then which we have to consider. For that, first we will simplify the signs into a single sign. For example, this will be 4 by 5 plus minus minus 3 by 2 minus minus plus 4 by 3, and this will be same minus 1 by 2. So this will be our first step to convert two signs into a single sign. That is very simple. If they are same sign, it will become plus. If they are different sign, they will become minus. So plus minus minus and minus minus plus. Now next step will be finding LCM of this 5, 2, 3, again 2. Simply 5, 2 and 3. You can check by finding its LCM, it will come 30. Okay, now next what we have to do, we have to convert all these numbers and by making its denominator 30. Now to make 530, what I will do, I will multiply it by 6. Same 4 should also be multiplied by 6. For converting 2 equal to 30, what I will do, I will multiply this by 15. So this should also be multiplied by 15. Whatever changes we will do with denominator, same changes will be done with numerator also. Now next is 4 by 3. 3 will become 30 when I will multiply this by 10. The main rule is of denominator only, so you have to check first the denominator. Then this 2 should be multiplied again by 15. Here also 15. So now all denominators will become 30, 30. This was our first step to make all the denominator same, and that also equal to the LCM of those denominators. 4 6 are 24, 15 3s are 45, 4 10s are 40, and 1 into 15. Okay, then simply what you will take, you will take all the denominators together as a common denominator. Now you can see that you can write numerators at the top. 24 minus 45 plus 40 minus 15. What is the best way to solve such numbers? First add the positive numbers. This is plus 24 and this is plus 40. So when you will add those positive numbers, it will become 64. And similarly, add these negative numbers together. So 45 and 15. 40 plus 10, 50 and then 60. So it will become minus 60. Plus plus I have added together and minus minus I have added together. Upon 30. So 64 minus 60, this will be 4 by 30, which is 4 and 30 both are coming in the table of 2. So what we can do, we can simply simplify. Now this can't be solved more. It is a proper fraction, so we can't convert it to mixed fraction also. So in this way, by simple calculations, by using the concept of fraction, here I have used the concept of fraction, but here I have used the concept of integers. So by using both the concepts, what we have done, we have solved this given problem. Similarly, here you can see it's simply multiplication. In multiplication, okay fine, it's very clear that we have to multiply all the numerators together and we have to multiply all the denominators together. Now what about these symbols? So what we have to do, we have to just count all the number of negative signs. That how many negative signs do we have in all. So I can count it here. This is one negative sign and this is another negative sign. So I have in total 2 negative signs. So if the number of negative sign is even in number, like 2 negative signs are there or 4 negative signs are there, 6 negative signs are there. So in that case, our final answer will be positive. But if the number of negative signs are odd in number, like 3 negative signs, 5 negative signs, then our final answer will be negative. So here you can see what I will do. First I will write all the numerators together at the top by multiplying. Similarly, all the denominators together by multiplying. minus sign and minus signs. Two negative signs are there, so they are simply cancelled with each other. So simply I have to solve this now. Now we can see this 5 and this 5 is cancelled. 5 ones are 5 and 5 threes are 15. Okay. 7 into 3 is left. One more 3 is left. At the bottom I am having 35 and 9. Okay, this much we have been left with. Now 3 3s are 9 and this is also 9. So this all will be cancelled. Now 7 and 35 both are coming in the table of 7. So 7 ones are 7 and 7 fives are 35. So this is our final answer. So in multiplication we have to check if something is being cancelled in numerator and denominator. So first we will cancel it. This makes our calculation easy also. There is another question in which we can see the question numbers are written, and in this we are having multiply sign also, minus sign also, plus also. And one more thing I have observed that 3 by 5 I am having 2 times. Okay, and the question is solved by using some property. So whenever there is any question, first you have to observe that question properly. You have to see all the numbers, just analyze it, that what we can do with these numbers. Okay, so once I have seen these numbers, I have found that 3 by 5 is repeated 2 times. One is with 3 by 5 into minus 2 by 7, and the another is with minus 3 by 5 into 4 by 7. So these are two multiplicative pair with 3 by 5. So once just recall all those properties which we had discussed: closure property, commutative property, associative property, distributive property, additive identity, and multiplicative identity. So once we will recall all this property, and we will just try to think that which property we can apply. And one hint I can give you, that whenever we are solving any questions, then there are mostly the questions in which we can use distributive property. Distributive property is mostly used in while solving the questions, whereas remaining other properties are used just to check whether they are satisfying the property or not. So in this I can say that 3 by 5 is distributed to minus 2 by 7 also, as well as 4 by 7 also. So what I will do first, I will write this pair together. My 3 by 5 into minus 2 by 7, then plus minus 3 by 5 into 4 by 7, and this minus 1 by 14 I have written at the end. Okay, this will be my first step to write both the pairs together. Now in this pair and in this pair, what I will do, I will take out 3 by 5 as common. Now please notice this, I have taken 3 by 5 common. So in this case 3 by 5 is coming directly, but in this case it is minus 3 by 5. So where has that minus gone? I have shifted this minus to this 4 by 7. So what I will do, I will write it like this: minus 2 by 7 will be here, then plus, this is plus, and this minus has been given to minus 4 by 7. Since we can't write two signs together, that's why I have kept minus 4 by 7 in bracket, and then this minus 1 by 14. Now as per board mass, first of all, this step is by distributive property. That property you have to mention which you have used to solve it. And the first step was just by rearrangement. I have done the rearrangement of the numbers. So this is just by rearrangement. Then by distributive property, I have taken 3 by 5 common from both these pairs. Now from this pair only minus 2 by 7 is left, and from this pair 4 by 7 is left, and its minus sign has been given to 4 by 7. Now first of all I will solve the bracket. In bracket you can see that both the denominators are same. So there is no need to apply LCM. But here two signs are there. So first I will make it into a single sign, plus minus minus. And this is minus 1 by 14. 7 will be taken as common, minus 2 minus 4. 3 by 5 into, now this will become minus 6 by 7. Okay, and this is minus 1 by 40. So once I will multiply 3 in, this is now board mass, here I am having one multiply sign and minus sign. So as per board mass, first we will multiply or subtract. M is coming first, BODMAS, S is coming last. So first we will multiply. So when I will multiply these two numbers, 3 into minus 6, this will be minus 18 upon 35, and this will be minus 1 by 40. So now next one denominator I am having as 35 and the another denominator is as 40. So first we have to find the LCM of 35 and 40. You can check, it will be 70. LCM of 35 and 14 is 70. So minus 18 upon 35. To make it 70, I will multiply it by 2. Again by, so numerator should also multiply by 2. And for this, 14 should be multiplied with 5. So 1 should also be multiplied with 5. So this will be minus 36 minus 5 upon 70 minus 41 upon 70. This is my final answer of this problem. Now this is proper fraction and 41 and 70 are not coming in any of the signal table. So we can't simplify it further also. So here we can end our answer. So you can see from the top to the end what we have done. We have done all the operations of fractions also, all the operations of integers also, as well as we have used distributive property in the beginning. So how we have come to know that we can use this property just by observing the question carefully and finding that one number is being repeated twice. So in this way we can solve any question. How we can represent any rational number on number line? There are only two steps which we have to consider while representing any rational number on number line. It's very easy as well as interesting also. First we have to check whether the given rational number is positive or negative. If it will be positive, then definitely it will be represented on the right side of number line. That is on positive side of number line. If it's negative, then it will be represented on left side of the number line. So positive will be represented on right side and negative will be represented on left of 0. What we have to check is that check the denominator. We have to check that what is the number of that denominator. Check the denominator and divide the intervals of number lines into that many equal parts. Like as by seeing the value of denominator, we have to divide the whole number line into that many equal parts. Now we will understand it in a better way by taking two examples. We have to represent minus 3 by 5 and 8 by 3 on number line. First I am going to represent this minus 3 by 5. Now the first step, check whether it's positive or negative. So by seeing the negative sign we can find that this is a negative rational number. So negative rational number should be represented to the left of 0. So first of all I will make my standard number line. This is my standard number line. 0 I will show. Now since there is no use of positive, still I will just show one positive number to show that this is a standard number line. Then on this side minus 1 and this is minus 2. This is the standard number line which I have drawn. Why I have shown more number on negative side? As I have to represent a negative rational number, and here just for formality I have shown one positive number. So you can see that in a number line it's very important to have equal distance in between each number. I have tried to make it equal distance between 0 and 1, then 0 and -1, then -1 and -2. This is first as my standard number line. Okay, and this is first step. Then negative means it has to be represented on this side. Now the second step is check the denominator. I have checked it. It's 5. Means I have to divide the intervals. These are intervals of number line. This is one interval, another interval, and another interval. So I have to divide this intervals of number line into that many equal parts, like in 5 equal parts. So I will try to make its 5 equal parts. To divide this into 5 equal parts, I have to draw only 4 lines in between. You can see like 1, 2, 3 and 4. I have drawn only 4 lines in between. 1, 2, 3 and 4. But you can see these are 5. It is divided. These 4 lines is dividing this whole interval into 5 equal parts. You can see how. This is 1, then 2, 3, 4 and 5. So this is 5 equal parts in this 0 and -1 interval. So from here I will start counting. This is 0. This will be, this part is one part of this 5 parts. If I will talk about this part only, this is one part of this 5. So this will be -1 by 5. And this will be -2 by 5. And this is my main number which we have to represent, that is -3 by 5. And then this will become -4 by 5, -5 by 5. 1 is also written as -5 by 5, and so on. If we have to find more rational numbers, we can move to left side of 0. So simply what I have done, to make 5 equal parts, I have drawn 4 lines in between, because one line is already given. So you can see that this is 1 part, 2 part, 3 part, 4 part and 5 part. By drawing 4 small lines in between, I can get 5 equal parts. So in this way, I have represented this negative rational number on number line. Now we will take one more example. This is 8 by 3. 8 by 3 means it's a positive rational number. So again, let's draw the standard number line. This is 0. This is 1. Sorry, -1. On this side I will have 1. Then 2. I can show here 3 also. So this is my standard number line. Now since the number was positive, so I have shown more numbers on positive side, and just for the formality I have shown one negative number also to make it a standard number line. So this is the standard number line, and you can see that they are at equal distance, 0 to -1, 0, 1, 2, 3 like that. Okay. Now the second step we have to move on, that is to check the denominator. I have checked the denominator, it's given 3. So I have to divide these intervals into 3 equal parts. To make 3 equal parts, like for example, I will divide only the positive intervals because this number is positive. To make 3 equal parts, I have to draw only 2 lines. You can see that while drawing 2 lines, I am getting 3 equal parts. So whenever you will check the denominator, make it 1 less and make that many lines in between the interval. So if it was 3, I have drawn only 2 lines. If it was 5, I have drawn only 4 small lines. So this is 0. This will be 1 by 3. Now from this 3 parts, this is 1 by 3, 2 by 3. And this is 3 by 3. Then again 2 equal parts. So this is 4 by 3 and this is 5 by 3. This 2 will be taken as 6 by 3. 6 by 3 you can check, it's coming 2 only. Now again 2 equal parts. This is 7 by 3 and this is 8 by 3. So what we have seen, this was 0, 1, 2 and 3. So this 8 by 3 is coming between 2 and 3. Now this 3 can be written as 9 by 3. So you should not worry more, just you have to check the denominator and you have to divide all the intervals into that many equal parts. For dividing that you have to take you have to divide into that many lines by taking one less than the given denominator. Then you can start counting from the beginning. This will be 1 by 3, 2. From these 3 parts, this is only one part. So 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3, 6 by 3 is again 2, 7 by 3, 8 by 3. This was the number which we have to represent, 8 by 3. And you can, if this is 8 by 3 is also improper fraction. So when you will convert this 8 by 3 into mixed fraction, then see 3 2s are 6. It is coming 2 and 2 by 3. So same is the number from the number line also you can see this is 2 whole and then this is 2 by 3. 2 whole and 2 by 3 which is 8 by 3. So I think you all have understood how we can represent any rational number on number line. For that you have to take care of only two things, that whether it's positive or negative. If it's positive, then show more numbers on positive side. If it's negative, then show more numbers on negative side. And then we have to check the denominator. By checking the denominator, we have to divide those intervals into that many equal parts, which we can do by taking one less than the denominator and making that many lines in between the interval. And then we can start numbering from the beginning. So now we will cover the last topic of this chapter, that how to find rational numbers between two given rational numbers. Now there is question that how many rational numbers can we find between any two given rational numbers. Supposedly these are my two rational numbers, then how many numbers can lie between these two? Can be counted, or are they limited rational numbers between these two? The answer is no. We can find infinite rational numbers between any two given numbers. So if it's not rational also, supposedly 2 and 3. Between 2 and 3 also there are infinite rational numbers. Between -5 and -6 also there are infinite rational numbers. How to find rational numbers between two given numbers? The first point is there are infinite rational numbers between two given numbers. Let's first start taking a very simple example. Like my first question is, find 5 rational numbers between rational numbers between 2 and 3, or we can take it as -2 and -3. So first thing, they want to know rational numbers, but -2 and -3 are not looking like rational number right now because it is not in the form of P upon Q. So we have learned that when there is nothing in the denominator, we will take it as 1. Now the answer will become -3 by 1. So these are two rational numbers. We have to find 5 rational numbers. So the logic is very simple. What you can do, if they want to know 5 rational numbers, then take one more than that is 6. Okay. So what I will do, I will multiply whole numerator and denominator by 6. Since you can see that both the denominators are same. So now we can move to the next step, that is -2 by 1 into 6 and -3 by 1 into 6. Why I have taken only 6? You can, it's not compulsory to take 6 only. You can take any number more than 5. Any number. You can take it as 6, 7, 8, 9, 10, 20, 100. Whatever you feel so. That it's very easy to calculate. But to find minimum 5, we have to take minimum 6. At least 6 we you have to take to find minimum 5 rational numbers. So it will become minus 12 by 6 and it will become minus 18 by 6. So the 5 rational numbers in between this are minus 13 by 6, minus 14 by 6, minus 15 by 6, minus 16 by 6 and minus 17 by 6. We will not include these two numbers because we have to find between. So we will by excluding these two numbers, we have to find other 5 rational numbers. So we can move to this step only if the denominator is same. If the denominator is not same, then our first step will be to make the denominator same. So you can find 5 rational numbers. If they want to know, find 20 rational numbers. So you have to multiply both the numerator and denominator by at least 21. At least 21. You can do it by 30 also, 40 also, 50 also, 100 also, by which your calculation becomes easy. But at least if they want to know 20 rational numbers, then you have to take at least 21. If they want to know 10 rational numbers, then you have to take at least 11. I am talking about the minimum number which you have to take to find the exact number of rational number between two given numbers. So these are 5 rational numbers. You can find many more depending on the question. Now similarly, I will just change this question. Supposedly this is minus 2 by 7 and this I am taking as 3 by 2. This is my 2 rational numbers and I have to find again 5 rational numbers I have to find between these two numbers. So what I will do? First I can see that in this case the denominator is not same. So first I have to make the denominator same. The LCM of which we can do by finding LCM. The LCM of 7 and 2 is 14. So this will become 7 into 2 and minus 2 into 2, and here also this 2 should be multiplied with 7 to make it 14. This is minus 4 by 14 and this is 21 by 14. Now they wanted to know 5 rational numbers. This is a net. Now I have made both the denominators 7 and 2 equal to 14. So 7 into 2, 14. So 2 should also be multiplied with 2. And then 2 into 7 is 14. So this should also be multiplied with 7. So this is minus 4 by 14 and 21 by 14. So I have to find 5 rational numbers. So in this case you will think that we should multiply both numerator and denominator by 6. But before multiplying it, just check that if I am finding 5 rational numbers without multiplying, then there is no need of multiplying it by 6 and 6. Okay, so you can check. This is minus 4. Just imagine the number line. Minus 4 by 14 is on left of 0 and 21 by 14 is on right of 0. So directly I am finding 5 rational numbers. Minus 3 by 14, minus 2 by 14, minus 1 by 14, 0 by 14, 1 by 14 and 2 by 14 also. I am finding many more rational numbers, but I will write only 5 rational numbers between minus 2 by 7 and 3 by 2. So in this way we can find as many rational numbers between two given numbers. So only 2 steps we have to take it if the denominator is same or not. If it's not same, we have to make it same by finding LCM. And after finding LCM also, if the denominator, if we are not able to find sufficient rational numbers as given in the question, then we can multiply it by any other number by multiplying all numerators and denominator with that number. So in this way we can find infinite rational numbers between two given numbers. So students, in this high time when our country is fighting with such a disease, so we all have to stand together with our country and we have to follow all the rules and instructions given by the government, and we have to take care ourselves only, because doctors are taking care of our whole country, nurses are taking care of our whole country. We have to support them, we have to stand with them. Thank you, students.